it's a graph related problem where we need to find if path exists in this given graph. So what we are going to do is given destination and from source, let's take an example. So if source is 0, and then from here it is asking if there is a path to 2. Yes, we can see that there is a path. This is a bidirectional graph, so there are actually two paths from 0 to 2, and then 0 to 1 and 2. So yes, we can clearly say it is true. And this one, it's asking from 0 to 5, 0 to 5. We can see that there is no path, so we will be returning false. So this is just like a basic graph traversal, and then when we are traversing it, if we see the destination for given node value, if it equals to it, then we can say it's like we have seen this one, and it's like there is a path, and we can just return true. If not, we will just keep traversing it. So we can traverse it in BFS or DFS fashion. So for this example, we can do a BFS. So let's start right into coding. So let's code it up. So first at first, I'll create a graph with the help of map. So it will contain, for given edge, it will contain the list of all those edges. So this will be my graph. Okay, now all we need to do is just like traverse into our edges, and from here we can see a so edge. We can just create some variables to keep these values in here, so not to get messy when we are just writing in the later code. So here, for when we are computing for graph, there is a method compute if absent from map, which actually makes it a little nicer to have, because like otherwise we would have written some lines of codes just to do this. So basically what we are doing, we are saying it's like if computing for given key for a, if it doesn't exist, then we can just like say given for value, we could just create new array list for it, and this method actually returns the value, so we can add the edges. So if we take an example, so 0 to 1, so we are seeing 0 and 1, so we can say, you can see 0 to 1 from here. So for 0 key as an edge, it is pointing to 1. So A is our 0 and B is our 1. So A is pointing to B. And it will be the same thing vice versa, because this is a bidirectional. So B pointing to A. So 1 to pointing to 0, or 0 pointing to 1, because it's a bidirectional. Okay, so now we initiated our graph. So for graph traversals, we need to keep track if we have seen the edges or not. So even for both BFS and DFS, we need to do that. So let's create our tracker, which will be boolean seen, and new boolean. It will be a number of edges, and we can see that we saw our source because we were about to process this, and we can create our queue because like it's going to be a BFS traversal. Okay, now we can just add last to our queue the given source. Now in this example we have added 0 into our queue. Now let's do the traversal. So while queue is not empty, we will remove the value from queue, we'll pop it. So int value queue remove, we have added to last, we're removing it first. Now we can actually see all those edges. So now we popped this 0, 0 was pointing to 1. Now we need to see this 1 as well. And so when we pop this 0, we can actually, before we process it, we can actually compare if this v is equal to our destination, because like, is it the one we are seeing? If it is, then we can just return true. Now let's go over its adjacency list, basically. Now it is saved in our graph, so when we're saying get v, this is returning us a list, adjacency list. So for each of this adjacency list, we can actually start traversing it. So int, so for all those edges in here, you can actually say next node, like from 0 to 1 right here. Now you can say it's like, have we seen this? If we have not seen this, then process it. So if we have not seen the next node, then start processing it. So now once we are processing it, we can mark it, we have seen this. For next node, now we can say true. So next time we will not be processing this. And we can add to our queue now. So now we'll start processing the next node right here. So if everything goes through, because like this is what we are looking for our answer, true. If it doesn't satisfy this condition where it is equal to each other, then we can say it's just false, because like we traversed everything and we couldn't find the answer. So let's run our code. Let's submit it. So time complexity, it's O of n, because yeah, it was accepted, because we n is all those edges in our graph, and we are using extra space, so this is also O of n.